a line?
No.
No, because it goes on and on forever, right? It doesn't stop. Can you measure a plane?
Yes.
Technically, no, because planes do go on and on in 2 dimensions, so we can't measure a plane.
Does this go on and on?
Well, that's not a true plane.
True plane? What do you mean?
A true plane does not have an ending to the 2 dimensions. It keeps going on and on forever. Can you measure a ray? Nope. Can you measure a line segment?
Yes.
Yes. So when we talk about measuring things, we're going to be talking about measuring line segments. So today we're going to focus strictly just on line segments. So the first thing that we have coming up here is something that's called the ruler postulate. We all know what a ruler is, right? Do we know what a postulate is?
No.
No. Does someone know what a theorem is? Yeah, what's a theory? A theorem. Not a theory, a theorem.
Is it theorem?
Well, sometimes people have theories on things, and they don't necessarily become a theorem. So a theorem is something that has a proof to it. Someone in the world proved something, and that's why we call it a theorem. Like the Pythagorean theorem, okay, is a squared plus b squared equals c squared, right? So, okay.
The theory of evolution is still the theory of evolution.
I don't know. Ask your science teacher. So, a postulate, Ryan and Nolan, 5 please. A postulate, guys, a postulate is similar to a theorem, but there is no proof behind it. So, it's a statement that we just say it is because it is. The sky is up. Has anybody proved it? No, but we just assume it to be true because we all know the sky is up.
It might not be though.
Okay, so the ruler postulate tells us that the points on a line can be matched 1-to-1 with the real numbers. The point on a line can be matched 1-to-1 with the real numbers. What does that mean? If I call this this is a line down here, and I want it to make my point here and my point here. The ruler postulate says your ruler has a number line on it, right? There's numbers on there. Can match up with points. Right? No duh. Yeah, I can match that up with my ruler. We're all capable of matching up my ruler. Okay, so that's all the ruler postulate says. I can match up my points up here. Can anybody see what's the length of this? I did pretty good. That's about 10 inches, we'll say. What if I put my ruler here and started at 2? Did the length change? Because now it's ending at 12. Did my length change of the line segment?
No.
No. How do I get 10? What do I do with 12 and 2? I subtract them, right? Okay, so the ruler postulate, all it says is that you can have 2 points. Your ruler, which is the real number line, can match up with it. Now, the numbers that are on the ruler are called your coordinates. You guys have heard coordinate plane before, but now we're going to think about the numbers on that ruler. So the real number that corresponds to the point. It's the real number that corresponds to the point. So right now my real numbers are 0 and 10. If I shift my ruler, now my coordinates are 2 and 12. Okay, so the coordinates are the number that it matches up. If I shift it to 1, now my coordinates are 1 and 11. Okay? All right, distance. What does distance mean? What am I looking for when I'm talking about distance? How far something is from one point to another point, right? If I wanted to find how far I need to travel this weekend to go to Stowe, Vermont, point A would be where I live, point B would be Stowe, Vermont, and then I would find the distance. Okay, so let's think about this. What's the distance from point A to point B using my ruler? It's 10 inches, right? If I shift it, it still stays 10 inches. What do I do with the coordinates of 2 and 12 to get to the 10? We already said this. We subtract them. What's another fancy word for subtract? Starts with a D, I, F, F.
Difference.
Difference, right? Difference means subtraction. Can distance ever be negative?
Yeah. No.
So if I walk backwards, am I walking back negative 3 steps?
No.
No, I'm still traveling 3 steps. So distance can never be negative. So what can we do to numbers to make sure they're always going to turn out to be positive?
Oh, I know. The absolute value.
Perfect, absolute value. So for our distance, this is what we're going to think about distance being. It's going to be the absolute value. Because distance always needs to be positive. And when I take the absolute value of something, that assures me that I'm going to get a positive number. It's the absolute value of the difference of the coordinates of A and B. So if my coordinates are 0 and 10, what's the difference? 10, right? What's the absolute value? 10? 10. If my coordinates are 2 and 12, what's the difference? 10. What's the absolute value of 10? 10. Okay? So distance technically is taking the difference between 2 coordinates and taking the absolute value of it. Now for the naming piece, so far, for our naming, we've had this. What does this mean?
Line AB.
Line AB. What does this mean?
Line segment AB.
Keep going. And what does this mean?
Ray AB.
Perfect. So now what's going to get added to the group for distance, if you ever see any 2 letters, we're just going to use generic A, B here. If you ever see 2 letters next to each other with no symbol above, that means you're looking for the distance or the length. Okay? So this means that we're looking for the distance between A and B, or the length of line segment AB. All right, let's see how our ruler capabilities are here. What are the 2 different units on a ruler? Centimeters and inches. Which one's the easier one to measure with?
Centimeters.
Centimeters. Why, Dominic?
Because it's in units of 10.
It's right. So it has units of 10 in between. So go ahead and take a look at your ruler that I gave you. Might be a little bit easier to see here. So the newer rulers don't have numbers here. I think they just have the tallies. But between 0 and 1 on the inches side, you have how many units? Bless you.
8.
How many lines? 1, 2, 3, 4. How
8.
many is it? Nope. 16.
Oh, yes.
You end up with 16. So if I go 1 unit, that gets me to 1/16. 2 units is 2/16, which reduces to 1/8.
Yeah.
3/16. 4/16 reduces to 1/4, and so forth, all the way up to 16/16, which reduces to 1. Okay, so inches is a little bit harder. Centimeters are much easier because you have 10 units in between, and what do we call those units? Millimeters. Okay, so if I were to measure up to this point right here, this line, how many centimeters is that? Well, we went 1, and then 1, 2, 3, 4, 5, 6. So all I would have to say is 1.6.
Yeah.
Then 1.7, then 1.8, then 1.9, then 2, 2.1, 2.2, and so forth. So centimeters are easy because you just count how many units beyond it and make it a point. Inches get a little bit more tricky.
I have a question.
So flip on to the back. Look at the ruler that they have for you. What's your question?
Why did we make inches if centimeters and millimeters are so much easier?
Because we wanted to feel superior above the metric system and make the English.
No, it's
So if we look at line segment ST here, what would be the coordinates of S, or just the coordinate of point S? It's at 2 centimeters. Good. What's the coordinate of T? 5.4. So what would be the length of line segment ST? It would be the 3.4, right? Because distance is the absolute value of the difference. What's 5.4 minus 2? 3.4. Is that positive? Yes. So ST's length, so that's what this means, the length of ST is equal to 5.4. Don't forget your units. We're talking in centimeters. Sometimes what I like to do is just count 1, 2, 3 centimeters, and then it's 0.4 over. Can also get you there too. That is easier for you to think about instead of subtracting. All right, now let's really try out our ruler work. So our first object, does someone say something? Do you need to go back?
What was it?
Oh, it is 3.4. Sorry. Thank you, Jimmy. Thanks for saying that. It's 3.4. I don't know why I wrote 5.4.
I just didn't understand why I did that. So
Thank you for asking and clarifying. 3.4. Okay, so we've got the toothbrush. Let's all make sure we're measuring the same length. So I want you to measure from here to here in both inches and centimeters, and then we'll compare. Just measure. That's all you gotta do. I don't care. You're measuring it. Measure from here to here in both inches and centimeters. Try to be as accurate as you can. We'll compare and see how we do. Again, make sure you label your numbers so you know what it is you're talking about. Okay, so for the toothbrush, most of you guys are done with that. How many inches did you get for the toothbrush? 2 1/8. That's exactly what I got. 2 1/8. I'm going to use the 2 quotes up there to stand for inches. You can either do that or write it out.
let's measure the hockey stick.
I will get there when I get there. You're ahead of us. Centimeters is what? I got 5.5. Yeah, that's what I got too. 5.5. Okay, so for the eraser, let's do the bottom line. So go from here to here. What are we getting for inches? Yeah, about 1 1/8 or 1 1/16, depending on where you put your lines. Centimeters, you should have been around what? 2.8. Yep, that's where I was. Okay, good. Now let's go to the hockey stick. We're going to go from the top here down to the bottom.
The bottom of my group. Look where
Yeah, like if you were to extend the bottom of it. I got exactly what Nolan got. Maybe yours is somewhere close. 2 5/16 for inches.
I got 2 1/4.
2 1/4, so that would just be 1 down, because that would be 4/16, right? So if you got 1/4, that would be fine too, depending on where you went. Centimeters, what'd you guys get?
5.8.
I said 5.7, 5.8, somewhere around there. Okay? So for your homework, there is going to be a problem where you are going to need to have a ruler and measure something. Are you all going to have access to a ruler somewhere in your home?
No, I don't. Wait, if I still unpack and all that stuff.
You don't have a ruler?
No.
Well, then I can give you one to borrow for the weekend. If anyone else needs to borrow one, let me know. Okay, so you will have to measure some things. Hopefully we're good to go there. We just need to finish with segment addition, and then we'll be done with notes. We'll save congruency for next time. So segment addition is exactly what it sounds like. You're adding segments together. So if I had fingertips to fingertips, if I were to measure fingertip to my nose, and then nose to this fingertip, and added those two lengths together, would I get the same length for fingertip to fingertip?
No.
Hopefully.
Because
My arms aren't growing. We don't have time, Dominic.
No,
So for your segment addition, that's all it is saying is that if you have two segments that create a full line and you add them together, you're going to get a full length. So we have if the length of AB plus the length of BC equals A to C, then that has to mean that B is somewhere between those 2 points. And there's our diagram. So pretty much A, B, and C need to be collinear. So if I were to measure from A to B, and I were to measure from B to C, and that would be the same length if I added them together to A to C, then B needs to be somewhere in between them. All right, these last two examples are super easy. I'm sure you can figure them out before I even start talking about them. For the first example on the bottom, it's asking for what length? M to P. So find point M, find point P. How many units? How many units would it be between the two? 23, right? Because you would add from M to N, which is 5, plus 18, which would be 23. I'll go back to it in a second. Just get this in. So MP would be equal to 5 plus 18, which is 23. What about the second one? We want to find GH. What do they give us for information? Well, from F
36 minus 1
to H is 36. F to G is 21. So how do we find this?
I know. 36 minus 21.
Good. So if we, that's what I want to do, GH would be equal to 36 minus 21, which is 15. Okay, so GH equals 15.
So can I see that again?
Yep. All right, so we'll stop there. I'm not quite sure if there is a problem in your homework that has to do with congruency. If there is, you can try to figure it out. If not, just leave it blank and we'll get to it on Tuesday. Yeah, it's 225. 1225, right? For some reason, I feel like the